In this video, I'm going to show you how you can simulate a waveguide in an infinite baffle. The cases where it may be of interest to simulate an infinite baffle as opposed to in a cabinet is when you're interested in the high frequency behavior of a waveguide or horn. The reason for this is that it's a lot more computationally efficient to just use an infinite baffle as compared to having to mesh the entire cabinet. While the infinite baffle does really quite drastically affect the radiation pattern at low frequencies, at higher frequencies you can get a very good picture of how the waveguide or horn behaves in an infinite baffle. So in this case, I have made a simple model. This model will have much lower resolution than what I would suggest you should use for high frequency simulations, but it'll be good enough to give you an idea of how a simulation like this works and how you can do it yourself. So to start with, I'm just going to go to the Components tab and I'm going to open the mesh file I've made. In this case, it's the infinite baffle example. And I'm going to go to scaling. I'm going to set it to 1 millimeter. Click apply, and here we have the drawing. So you can see that there's some mesh elements in front here with the normals pointing inwards. And this is because we have to separate the front and the back of the infinite baffle. And so we need an interface. So we're going to have two subdomains in this case. It's going to be what's inside this interface, and it's going to be the exterior, which is where the infinite baffle itself sits. So in this case, we should have everything selected. Everything looks fine, other than the fact that the resolution is quite low. But again, that is intentional. You should not use resolution this low if you're simulating to a high frequency. Okay, so we click apply, we close this, and now we can create our subdomains. So we go to the BM tab, we click on subdomains. This is going to be just interior. And we can see here interior selected, click apply and close. And now we're going to create another one, which is exterior. And here we can see we chose exterior as our option. So we click apply and we close. In addition to this, we need an interface. So we're going to click on interface. And here the subdomain 1, which is where the interface is pointing in towards, is the interior. As I showed you earlier in the mesh file, the normals were pointing in towards the waveguide. And then subdomain 2 is of course the exterior. So we click apply and then we close. Now we have two subdomains and we have an interface to connect them. The next part we're going to do is we're going to choose elements mesh file and we're just going to model the interior. So click OK. And we go to the drawing, and now we have the waveguide. So we do not want the interface in this case. So we're going to remove it. Here we can see it's these parts. So it's 5, 6, and 7. So now we have just a waveguide. We have to remove the driver too. So here we have just a waveguide, just like we want. And then we just click apply. And that's all fine and dandy. So now we can close this and we click on mesh elements again, choose interior, and this time we're going to model the driver. In this case, we're just going to click everything off except number 4, which is the driver here. And we're going to go to boundaries, choose driven, and in this case as well, the driver is flat, it's a compression driver, so direction, normal to surface is completely fine. Click apply, and now we can see we have these red elements here, which indicates they're driven. So the next part we're going to do is we're going to add the interface. So we're going to go to elements mesh file again, but this time we're going to choose interface 1, click OK, and on the drawing we're going to choose only these interface elements. So this part right here and this part right here. And these are the parts which connect our interior subdomain to our exterior subdomain. So all off, and then we just choose this. So here we can see this is the interface. Click apply, and now if we turn this around a bit, we can see here that it's blue, just as it should be. So all around the waveguide, every point in which the waveguide connects here, there's a blue interface. The next part is adding the infinite baffle. So we're just going to click on this infinite baffle menu, and we're going to choose exterior. Click OK, and now we can see it's the wrong direction. You can see here, it's in the x-axis direction. So we're going to change the position, just set it to C, and now we can see here that it's flush with our waveguide. And now we can simply close this. We don't really need to do anything more. As long as it's the right direction, everything is good. Now the next part is just adding the symmetry. So we go to global, we go to BM parameters, and for symmetry we choose XY in this case, since it's pointing in the C-axis. Okay, and there we have the waveguide. Looking good, looks just like it should. We can see here it's still flush with the infinite baffle, and now we can see that the interface goes all the way around the mouth of the horn or waveguide. So the next part is just simply adding the observation points we need. So we go to components again, we go to observations, choose radiation polar, for example, and this one can be radiation horizontal. And since this is an infinite baffle, we can't actually measure at plus minus 180 degrees because there's nothing behind this. So it's only plus minus 90 degrees. I'm going to set 5-degree increments, and I'm going to normalize it to the on-axis. But I am going to just, in this case, since we have an infinite baffle, I'm just going to normalize this to excuse me, I'm going to set the distance to far field. So it's just going to simulate from really far away, and then normalize the response to 1 meter. And then on position, I'm going to set this to CX. This is the horizontal plane we can see. So I can close this now, and then I can copy it. Just right click on this, copy, right click again, paste. And this time it's going to be CY instead of CX in position. Now we can see we have this, which is going to measure the vertical, and we're just going to give it radiation, and let's just call it vertical instead. Click apply, then we can close this. And then maybe we're also interested in the radiation impedance. So we can add that, and then we just check that the driver is right. Yeah, it's right. Click apply and close. Now that we've done this, the next part is just the same thing we always do. We go to global, which is frequencies, and let's just simulate up to 10 kilohertz again, because this does not have the mesh resolution to go really high in frequency. Even 10 kilohertz is a stretch. And then we just click OK. And now we have to go to global again, and we have to choose fixed driving. Since we don't have a lumped element model for this driver, and I'm not going to create one, we just need to set fixed driving so that it's actually giving us an output. If we don't set fixed driving, it won't give us any output. The weighting does not matter in this case. Click apply, close, and now everything is ready for simulation. So I'm just going to go to processing, I'm going to calculate all, and it's going to use a little bit to calculate. We can see here it has, the solving size is 732. This should go fairly quickly. So it took 19 seconds. So as we can see, it went fairly quickly. So now the responses should have been opened up in VAX. So I'm just going to click here, and here we can see the radiation impedance. It looks fine. It doesn't look too weird to me. And here we have the horizontal radiation pattern, and here we have the vertical radiation pattern. Now, an important part of simulating in an infinite baffle is that it will seem like it is much less directional at low frequencies than what it will be in reality. Here we can see at 90 degrees off axis, apparently this waveguide is only maybe 3.5 decibels down at 1 kilohertz, which does not really match reality. If we compare it to the same waveguide in a cabinet, which I just simulated, we can see that at 90 degrees off axis, it's more like 12 decibels down. So simulating in an infinite baffle is not accurate for low frequencies. However, for the high frequencies, it can give a pretty good picture of what to expect. And since you can get away with fewer mesh elements, since you can use all the you can use basically all the available processing power you have for just the waveguide and not the entire cabinet, which takes up a lot of mesh elements, you can simulate to a higher frequency. Now, in this case, I didn't. I made it really simple so that it would solve quickly. But that's really the big use case for the infinite baffle for waveguide simulation purposes. I do hope you found this useful. Thank you very much for watching.